Okay, handout 4.2. Let's do a quick recap. Simply just a quick reminder of a couple of definitions and terminologies. So remember, right, we have a random, what we call a statistical experiment or random experiment, right? So like, for example, we flip a coin, flip a coin, right? Flip a coin twice, or flip two coins, right? Same idea, right? This is we call this a statistical experiment, right, or random experiment. Why? Simply because it has well-defined outcomes, right? So all the outcomes we put them together in call it a sample space, right? And there are four outcomes possible, right? Heads heads, heads tail, tail heads, and tail tail, right? There is no other possible there's no other possible outcome. Okay, so if it's well defined, right, and each of these we can assign a probability to it, right, then we call this a statistical experiment. We do not know which one of these is going to be, but each of them are possible. Right? So this is a sample space. Each of them are sample points. Okay, now we also want to define events, right? So for example, if I define an event, right, an event is just a subset, right, subset of S of the sample space, right, a subset of the sample space. Okay, so I can collect, for example, my event A could be I only get I get all heads. Right? I can define that as my event. Okay, then that will be then I will look at which of these consists of all heads. Okay, so that's heads. That's the only one. Or I can define, let's say I'm going to define the event B, right? And my event B is that I get exactly one tail. Okay, so then I will look in here. How many events gives me exactly one tail? Tail heads and head tail. Okay, it's also two events. All right, so events from an experiment is a subset of the sample space. Okay, and then I still retain the probability on each of these sample points. Right, that probability or the chances of each point happening does not change. Okay, but then that does impact, right, the chance of the event happening. Right, so for example, right, what's the probability of A? Okay, so we can say, well, the probability of A, right, is 1/4. Right, because I have one element here, and again, like, this is assuming that each four are equally likely, so I have 1/4 here. What's the probability of B? Probability of B, well, 1, 2, so 2 out of 4, so 2/4 or 1/2. Okay, all right, so okay, now we have events, right, and we have different definitions and relationships that we want to be able to talk about. So that's what this part is going to be. All right. So first, complement. Okay, so what is a complement? Here's a good visual. Right? You have a sample space, so that's everything. So event A complement is just a quick way of describing all the points that's not in there. So let's roll, pun intended. Let's roll with this example for the rest of the handout. Okay, so I have a dice roll. Okay, so my dice roll, my sample space is 1 through 6. Okay, and let me define A simply as the odd number. So that's 1, 3, 5. Okay, then my A complement, right? My A complement was my A complement. That would be everything that's not in A. Okay, and so that would be in this case, the even numbers. Right? Okay. Now, again, so A and A complement have to include everything. Okay, so that's just a quick way of describing everything else. All right, union. Okay, so union. Another way to read union is A or B. Okay, so we read. It's a good way to understand what it means. Union is a U, so we write it as or. So it's basically anything that is in both. Right? Anything that is in both. So imagine if I say I want students and I want freshmen and sophomore. Oh, sorry, freshman or sophomore. Okay, so that means all of the freshmen and the sophomores will qualify. Right? So right? Right, as opposed to freshman and sophomore. Right? Then there's nobody that's freshman and sophomore. Okay, so continuing with my dice roll example, let me redefine A as So I'm going to define a new A as 1, 3, 4, 5. Okay, and I'm going to define B as 4 and 6. Okay, again, I'm going to do my dice roll. All right, and then so then what is A union B? Okay, so A union B basically is saying, well, all the sample points that's either in A or in B. Okay, so then I have 1, 3, 4, 5, and 6. Right, 4 is in both, so I don't want to double count, right? Because well, I'm just illustrating which sample points are there. So I do not write 4 twice. Okay, so 4 is in there once. Okay. Now intersect. So this is A and, so we write this as A and B. Okay, so then that's the only thing. So then we only consider the sample points that are in both, right? That qualifies qualifies both, right? So, all right. So let's continue with this earlier example, right? A and B. I'm not gonna redefine them. Then what in that case? Then what is A? What is A and B? Okay. So then what sample points are in both? Right. So in this case, there's only one. That is 4. Okay. All right. Let me give you another example. Suppose let me define a new event. This new event is 1 and 3, and then event 2 is 2 and 4. Okay. Then in this case, what is event 1 intersect event 2? Right. There are no sample points that's in both events, so the answer is nothing. Now we don't write 0 because 0 is a number, right? 0 could be a sample point, right? So we do not write 0. Instead, we use this symbol. Okay, this is pronounced null. Null means empty. Okay, so null, right? We call this null. It just means empty set. So this is an empty set. Okay, continuing again, we're gonna keep going with our dice rolled example. So I'm just gonna rewrite the sample space here as a reminder, like this is the sample space we are working with. Okay, all right. So addition law. So addition law gives you a relationship between union and intersect, but it's a reminder of you have to subtract, right, the intersect when you add these. So for example, I have A equals 1, 3, 4, 5, and then B equals 4 and 6. So continuing with that. All right. Now let's see here. What's the probability of A? Probability of A is 4 out of 6. So 4, 6, or 2/3. Okay. Probability of B, right, equals 2, 6, or 1/3. Okay. All right. Now, what if I want? So I want the probability of A or B, A union B. Now, if I simply add them together, 2/3 plus 1/3, right? Then I'm going to get 1. Okay. Now, clearly, there's an element missing here. That is the element 2. So if 2 is missing from two is missing, I can't have, right, a probability of 1 because a probability of 1 tells me that A or B must happen, but that's not the case, right? So what happened here? Well, because I double counted 4, okay, so I need to take that out. So then I need to calculate what's the probability of A and B, right? I need to take away one of the intersect, all right? Now, I already figured out earlier, right, that A and B equals is the intersect is 4, so that's 1 out of 6, right? So it's 1 out of 6. So I have to subtract 1 out of 6 here. So that's 1 so that's 1 minus 1, 6. That equals 5, 6. Okay, so the probability of A or B equals 5, 6. Okay. And now these are just numbers. Okay, and I'm gonna say that a lot whenever I point out, in a formula, in an equation, I'm gonna say these are just numbers. Okay, and the reason why I'm pointing that out is because if these are just numbers, then you can do algebra with it, right? You are free. So if you have an equation and if these are just constant numbers, right, then you can move them around. You can feel free to move them around. So what I mean is, I can take this, I can rearrange everything here, and I can write this equation as A and B equals probability of A plus probability of B minus probability of A or B. right? I can easily do that. I can rearrange these formulas, and I can do that because these are simply numbers. Okay. Okay. Now, mutually exclusive events. Okay, so this is a simple definition. Okay. So two events are mutually exclusive if the event have no points in common. Okay. Now, this is going to be a slightly more important concept, so I'm going to put a star next to it so we can come back, or something that we're going to use later on in the semester. And you can see here, there is no overlap, right? There is no overlap here. All right, so we say if A and B, right? So here I'll just give you another example. If A equals, right, 1, 3, right, and B equals 4, 6, then A intersect B, right, equals the null space, right, equals null space equals empty. Then we can conclude that A and B, right, A and B, right, are mutually exclusive. Okay, and so this is a definition. Okay, so what that means is a definition. If you remember from your geometry class, right, definitions, right, goes both ways. So a definition, if true, then the converse is also true. Meaning, if A and B is empty, then A and B are mutually exclusive. Vice versa, if A and B are mutually exclusive, then we can conclude that A intersect B is the empty set. Okay, so they go both ways. All right. Okay. Now, what does that tell you then? As we can conclude is that the probability of A intersect B equals 0. Okay? Probability of A intersect B equals 0. Now, it does not mean that now you can't go the other way. So if just because probability of A and B equals 0, you cannot conclude that they're mutually exclusive. Okay, so this only goes one direction. So that's why this arrow is not a double arrow, but it's a single arrow in one direction. Most of the time it's going to be true, right? But I mean, most of the time, if you have this probability, you can conclude mutually exclusive. But they are exceptions. So don't make that mistake going backwards. So we're going to use, if it's mutually exclusive, the probability is the probability of A and B equals 0. Okay, conditional probability. Now this is also really important. Let me give you the definition first, the mathematical definition, and this is going to be new notation. So most of you have not seen this before, but that's okay. This is very easy. So let me write it down first. Okay, all right. So conditional probability is this: the probability of A happening given B happened already. All right, so let me write it out in words. The probability of A given B happened. All right, and this line in here, we read that little line there. We read that as given. Okay. Now, this is the way you think about this is adding an additional information, right, to this. Okay. So here, let me give you this. So suppose that A equals, right? A equals 1, 3, 5. Okay, and now this is going to be a silly but informative example. B equals 3. Okay, now here's my question. What's the probability that any one of these A, right, is going to happen, given that B happened already? Okay, you can pause and think about it for a second.